This PDIF splitter is a device that splits one incoming digital audio signal to 3 outputs. On the front panel there is a selector which is used to select the output. So by pressing the button you are selecting one of the outputs. This same function can also be achieved with a remote control. This is a radio remote control, not infrared. This is radio signal, so it doesn't matter how it is oriented, it always works. You don't have to point it to the source. So these have coaxial and Toslink splitter. For coaxial you need to select the output, while for the Toslink the signal is always splitted. So for Toslink, as you can see, design, Toslink you have one receiver and 3 transmitters which are always active. So one signal is always transmitted to 3 other, while for the coaxial you have to select one of the output, which is then switched with a relay. On the board there is a radio frequency receiver, Arduino, which controls all of it. On the front panel there is a holder which is 3D printed. This holder keeps the LEDs and button in a position. It holds LEDs. The holder keeps LEDs and push button on a position, otherwise there will be nothing that keeps them attached to the front panel. So this is it. It's a relatively simple design. Let's see the back panel. What we have. The back panel is, there is a power switch, there is a USB 5-volt input, 1 coaxial input, 3 outputs, 1 Toslink input and 3 outputs. The rear panel is made on a CNC router, as well as the front panel, and also the PCB is made from Pertinax, which is also etched on a CNC router. So everything is done on a do-it-yourself basis. There are no bought modules here. Everything is done at home. So I will show you briefly the process of manufacturing this little device, which is probably primarily intended to be used with for testing the ducts, to comparing their performance. Both front and back panel I made out of 3mm thick white acrylic. It is a white acrylic sheet which is relatively easy to machine. All the machining I did on my CNC router. The tool I use for cutting the holes is a 1mm flat end mill. Speed of the spindle was 20,000 RPMs. Feed is 300 millimeters per minute. First I cut the holes. After that I made a contour for this momentary push button. After that I made pockets for fixing bolts that fixes panels to the rest of the enclosure. And after that I made a cutout of these panels. In this situation, panels were ready to be painted. For painting, I use this acrylic color in a spray. I put a spray on it and return them back to the router. After finishing the painting, I returned panels back to the router for additional machining. This machining was done to remove the paint. First thing I did was pocketing these numbers. So all the machining after painting was done with 0.25 millimeter flat end mill. So all the engraving of these letters and numbers was done with this flat end mill. First I pocket the numbers. After that I engraved these letters on both panels. And that was it. I removed the color and I have finished front and back panel ready for assembling the device.